Bonjour, Dr. G here. Hey, part one, we talked about how coal formed. In part two, we talked about how coal is dug up out of the ground or blown out of a mountain. Now, once we extract the coal, how do we use that to create energy? And the process is pretty simple. The coal's shipped to a coal burning power plant. Now, before it's used to burn, it's ground into a very fine powder. And I mean, think about it. If you grind this coal into a fine powder, you're just increasing the surface area. Imagine this boiler here having large chunks of irregular shaped pieces of coal, and trying to light that might be pretty hard, and trying to sustain that might also be hard because of the shape. So when you grind the coal into a fine powder, you're increasing the surface area. It could burn hotter, and it could sustain that length of time more so than if it were regular shaped, all just jaggedy. So wash it and grind it. It's placed in the boiler, and in the boiler you have these pipes, and these pipes are filled with water. But then as the water is exposed to high temperatures from the coal burning, the water turns to steam, and the steam spins this turbine. And the turbine is like a fan blade. So there's a lot of pressure going through this small little pipe that spins this turbine, this fan blade, which is attached to a generator. And basically, a generator is two electromagnets, and they're facing each other. And when one is attached to this fan blade and it's spinning and it faces the other one, it creates an electron flow. And that electron flow is jacked up in amps, I'm sorry, in volts, and that high voltage power is sent through transmission lines to your house. And that is basically the gist of it. Now, this could be coal, but since we're talking about coal, it also could be oil or natural gas. Fossil fuels in general use the same method. A fossil fuel is heated to heat up water, turn to steam. The steam is used to spin a turbine. The turbine is attached to a generator. That spinning of the generator, when you have a magnet facing another electromagnet and one spinning, it creates an electron flow, and that electron flow then is harnessed and it's sent to your house. Bada bing, bada boom, done. That's how coal is used to form energy or to make energy. Now, there are two types of plants out there. The first type is called an open loop plant, and that's not all that great. Like, for example, let's just say this process takes place, what I just mentioned to you, and after the water is used to spin or the steam is used to spin a turbine, that steam is then condensed back to water. And sometimes that condensed hot water is discharged back into a river or a lake, and that could decrease the dissolved oxygen rates of that body of water. But a more environmentally friendly type of system is called a closed loop system. And yes, this is an animation of a nuclear power plant, but it's the same idea in a coal burning power plant. When that steam is used to spin a turbine, that steam is then condensed in the condenser back to water, and that hot water is then pumped back to the boiler and it's used again. And the reason why it's closed is because this loop is closed, it's not open. And that means that the hot water is not being discharged back into a body of water like the open loop system. Now, the open loop system most likely will have their own environmental scientist or chemist or biologist monitor the temp so it doesn't exceed the EPA limit so they don't get fined. But nonetheless, it could end up discharging hot water into a nearby body of water like a river or a lake, and that could harm it environmentally. Along with burning coal, and we just talked about one type of pollution, but pollution is something that we need to talk about that correlates or that is associated with coal burning power plants, or I guess I should say fossil fuel burning power plants in general. And the first type of pollution we already talked about. It lowers the DO. Well, closed loop systems don't because they're more environmentally friendly. In fact, it's probably more efficient because the hot water is pumped back to the boiler. So maybe you don't need as much heat to heat that hot water back to steam. Anyway, we know thermal pollution is associated with coal burning power plants. We talked about this in the atmosphere unit, where when you burn coal, you produce ash, and that dirty gas containing the ash is sent through an electrostatic precipitator. That electrostatic precipitator in the chamber has electrodes that are that are charged differently than the particles of ash. So it uses static electricity to attract the ash to these electrodes, and then cleaner gas comes out on the other end. That's great and all, but remember, the coal burning power plant operator, they have to go and scrape that ash, and then it totally solves an atmospheric pollution problem, but now that create a solid waste problem. And then wet scrubbing systems, like we talked about in the atmosphere unit. When you burn coal, you combust carbon and sulfur, and one gas that could lead to acid rain is sulfur dioxide. So as this sulfur dioxide rich gas is sent through a series of filters dipped in lime, that lime reacts with the SO2, and out comes gas that is rid of SO2. And by the way, as the SO2 gas reacts with the lime in the filter, it creates this solid calcium sulfate, and then that could be used for mixing in with concrete. And again, like we mentioned, the atmosphere unit, and I just said it 3 seconds ago. Now you have, with electrostatic precipitators, a solid waste problem, and you have to get rid of that ash somehow. And a perfect example of a retention pond failing is in the Tennessee Valley Authority. In fact, this 5.5 million gallons of wet fly ash was said to escape through that dam breach. 5.4 million gallons of fly ash that contained 44,000 pounds of arsenic, 49,000 pounds of lead, 140,000 pounds of manganese, and 1.4 million pounds of barium compounds all entered the environment. So here's where the wall failed, and that nasty fly ash, as you can see from these pictures, just swamped the environment. Estimate cost to clean it up, 1 billion buckaroonies. We also talked about, and this is not the first time you've seen this map. You've seen this map many times, actually. This is where the coal reserves are in the United States. And as you can see, that relates to air pollution related deaths. And we are smack dab right in the purple. And if you take a look over here, we're in coal country. So wherever most of the coal is being used to make energy, and that burning coal produces harmful pollutants into the atmosphere. We also talked about how burning coal is related to acid rain, the CO2, the SO2, and the NOx's that come out of coal burning power plants react with moisture in the atmosphere. And this map just shows the acid rain in terms of pH and how that correlates with where coal's found. What about soil pH? And here's coal, and if you notice that this is the slightly more acidic soil because allegedly of burning coal, which produces acid rain. So these are all the things that we need to be aware of that harm the hydrosphere that relate to burning coal, like mountaintop removal, and burning coal produces fly ash and acid rain. So again, think back to how burning coal affects the hydrosphere. Think back to how burning coal affects the atmosphere with acid rain and greenhouse gas emissions and mercury and water vapor when they combine, particulate matter, and how burning coal relates to the biosphere and how it harms especially strip mining and mountaintop removal. So that's all I have for you. That is coal in a nutshell. Thank you for watching. Bye-bye.